Hi, welcome back to Missing Chemistry. This is electron configuration titanium TI lesson. Titanium is the 22nd elemental periodic table, so we're going to write down an atomic number of 22. Its atomic mass number, the AMU, is going to be 48. So since the atomic number is 22, that means the nucleus has 22 protons. And since the atom is electrically neutral, it would have to have 22 electrons. What about the number of neutrons? Okay. Well, that's AMU minus protons equals neutrons. So we're going to go 48 minus 22 to give me 26 neutrons. You're going to put a 26 there, right? Now, before we do the electron configuration, it's important to remember that the S subshell can hold 2 electrons, the P subshell can hold 6 electrons, the D subshell can hold 10 electrons, and the F subshell can hold 14 electrons. We're going to use the off-ball principle, or the diagonal rule as it's often called, to do our electron configuration. We'll start right here and go down this red arrow and follow the red arrows until we run out of electrons. So we got 1 S2. Okay, pretty cool, huh? 2 S2. 2 P6. S2, 3P6, 4S2, and then we're going to stop at 3D, be 3D2. Pretty darn amazing, huh? Now, let's look at our orbital notation. That's doing Hund's rule. Remember that Hund's rule states that in every suborbit, you have to put an up arrow in every suborbit of that level until you can put down this down arrow. Well, S only has one suborbit, so we go up and down, right? We go up and down there again. Well, 2px, 2py, 2pz. Now watch how I do it. 1, 2, 3, 4, 5, and 6. Pretty cool. 3s, up and down. 3px, 3py, 3pz. Again, 1, 2, 3, 4, 5, 6. 4s, up and down. Then we have 3d x squared minus y squared, 3d xy, 3d yz, 3d xe, and 3dz squared. Do we need all 5? Because all we have is 2 electrons left. The answer is yes. Because remember that electrons, they can become excited, they can jump suborbits and orbits. So we can go up and then up. Pretty darn amazing, huh? Now let's look at our noble gas notation. The nearest noble gas to titanium is argon. So we're going to put argon in there. And then we're going to write our valence shell right beside it. And what's our valence shell? This right here, 4s2, 3d2. So we're going to go 3d2, 4s2, and we're going to put them in numerical order because that's the order. All right, now when you look at the quantum notation, the first thing you're tempted to do is write a 4 for titanium, but don't do that because remember, D block is n minus 1, right? So you're going to write 4 minus 1 to get 3. So the n value in this case is going to be 3. Our angular momentum is going to be 2 because in the D plot the value is 2. The m value, okay, titanium's the second element over, so you go minus 2, minus 1, right? So you're going to put a minus 1 there. And look at this last arrow. It's going up, right? So it's going to be 1/2 positive. Well, that's it for this lesson, guys. You be snarly, and we'll see you back here at Missing Chemistry.